All right, so welcome to another lecture for interactive computer graphics. We're going to speak a little bit of C++ today. So last time we talked about rendering algorithms, and I believe I hinted it a few times that we're going to be using rasterization for most of this, most of interactive computer graphics and most of this course. And today we're not going to talk about rendering algorithms per se. What we're going to talk about how to start doing anything that is interactive on using the graphics API. So the stuff that I'm going to talk about today is going to be related to our upcoming project. That's a relatively simple project, intentionally so. It's going to give you a chance to set up your environment and start things. I call it a Hello World project because we're just going to be generating a window and do some simple stuff with it, like change the background color. You can see the project description on the course webpage, so please do check it out and read it carefully. And the stuff that we're going to talk about today is going to be, I think, fairly relevant to that project. All right, so today's topic: windowing APIs for OpenGL. So we're targeting OpenGL in this course. So the stuff that I'm going to be talking about is going to be related to OpenGL, although there are similar stuff that you can find for other APIs as well. So what's a windowing API? What is that? Well, OpenGL is platform independent, or maybe that's not the best way of describing it, but OpenGL itself is not directly communicating with your operating system. So it sort of works on pretty much any operating system. But you'll need to do something with the operating system first. Well, you need to get a window from the operating system, right? You're going to need to do some things with the operating system before you can start using OpenGL. And that's what we were going to talk about today. All right, windowing APIs. So what does it do? Well, what we want is this. Okay, this is what we need: a window that we can draw stuff in, right? So I colored the background to something, but whatever. We're gonna put some image inside this window, and that's what we need from our operating system, right? So that part is going to be, system dependent, sort of operating system dependent. And then once we have this window, we can draw whatever we want inside this window. All right, so that's what we're going to need. So, all right, we got this window. It's just getting any window is not enough. We're going to have to do some initializations about OpenGL so that we can actually display an image that's generated by our GPU inside this window, right? So there's going to be some initialization related to that as well. Beyond that, remember, this is interactive computer graphics course. So we're going to be interacting with this window. We're not going to be just looking at it. We're going to be interacting with it. Like, how can I interact with a window? Or how can I interact with anything on the computer, right? I can just use my keyboard or my mouse or whatever, right? So I'm going to be maybe, rotating this teapot and do some things with it. For that, I'm going to be needing some user input. That input is going to come through the keyboard or mouse or controller, whatever device you attach to your computer. And we will need that data. So our windowing API will also allow us to access that data, access the user input. And we can also do other things that are programmed inside that API and do whatever we want with our teapot. All right, so we're going to be programming all that, but of course, all of that is going to be, the purpose of that is that it's going to be interactive. We should be able to interact with it, and the windowing API will allow that. So if we were to summarize, the windowing API is going to give us an operating system window that we can draw on. Our GPU is going to render on that window, and we will be displaying it inside that window. We will initialize the OpenGL canvas. So for example, we talked about Z-buffer rendering last time. You don't always need a Z-buffer. Sometimes maybe you're just drawing a triangle. Maybe you're drawing something 2D. If it's 2D, then everything is flat, then you don't have the depth. If you don't have the depth, you don't need a Z-buffer. If you don't need a Z-buffer, you don't need to allocate a Z-buffer and start doing Z-buffer tests and stuff like that. So if you initialize your OpenGL canvas without a Z-buffer, then things would be a little more efficient for drawing things in 2D. So there are different things that you can set when you're initializing OpenGL to get a canvas with the properties that you want. And there are different versions of OpenGL. You may want to get a specific OpenGL version for your canvas, and you can set it up as well. So all this stuff needs to be done by communicating with the operating system in different ways. Also, we'll need the input from our input devices. We need to capture them one way or another, and our windowing API will allow that, like mouse, keyboard, and controller and whatnot. Right. So what do we do? What do we use for this? Well, we can use various types of APIs. I'm just giving you some examples of APIs that we could use for OpenGL. And these are the ones that I'm listing here. They are platform-independent APIs. So they would work on Windows, they work on iOS devices, they work on Linux. So you can pick and choose and whichever one of these or anything else you want to use. So I'm not going to give you any restrictions on the types of windowing APIs you can use. You can really use any API that you want as long as it's freely available, so we can obtain it too. But my guess is that you guys probably will use one of these. That's my guess. But if you can think of another one that you want to use, that's perfectly fine too. And all of the ones that I'm listing here, they are platform independent, and they should work on any operating system. Among them, Glut here, OpenGL Utility Toolkit, is probably the most famous one in the OpenGL world. And the reason for that is that it's very old. How old, you say? It's very, very old. It's almost as old as OpenGL itself. So it's been around for quite some time. And, a couple of decades ago, people sort of start updating that API. It was good enough. It still works. But, it's not really updated for our modern operating systems. It's been around for a while, and it hasn't been updated for a long time. So to remedy that, this FreeGlut project came about. It's exactly the same API. Okay, I believe there are a few really minor differences, but other than that, FreeGlut is almost identical to Glut. So you might as well use this. This is a more recently updated API. It might work just a little bit better. You might have an easier time to get it working. If you're not sure what API to use, this is the one that I would recommend. Right? It's the same thing as Glut, so I'm going to be talking about Glut today, and everything that I will be saying is going to be related to FreeGlut as well. Exactly. As I said, the differences are really, really minor, and most of it is due to the need for adding some additional features in FreeGlut that Glut did not support. They only differ there, I believe, so given any code that was written for Glut, you could compile it using FreeGlut as well. Another API is this GLFW. I'm going to briefly talk about that one as well. It's an API that looks a little bit different. I've used it a few times, and it works just fine. I'm actually happy with it. So there's no reason for not using it. If you want to try it out, I would recommend it. So that one is also in my recommended list. You want to use Qt? Qt is a much bigger API. It's a much bigger API that contains so many more things than just giving you an OpenGL window that you can draw on. But if you're familiar with Qt and if you want to use Qt, that's perfectly fine. If you're not familiar with Qt and if you're just going to get into it because of this course, I would say don't do it. I call Qt a bit more invasive API, kind of totally changes the way that you write code. That's not necessarily bad. It makes certain things easier, but your code becomes Qt code. It's not like you're using Qt on the side. It's very invasive in that sense, but it's a pretty good API. If you want to use it, I would recommend it definitely. But if you don't know which one to pick, my recommendation would be just FreeGlut. That would be my recommendation. Or you could use this one as well. I wouldn't recommend Qt unless you really want to use it. All good? Okay, so in the rest of this lecture, I will be mostly talking about GLOT, and everything that I will talk about will apply to FreeGLOT as well. And at the end of the lecture, I'm also going to talk about briefly GLFW. Now, the goal here with this introduction to the OpenGL Utility Toolkit, my goal is not to give you a step-by-step tutorial. That's not my goal today, and that's never going to be my goal. But admittedly, today's lecture sounds very much like a step-by-step tutorial for the first project. So that's a little bit unintentional. So I'm not saying that I'm going to be talking about each and every line of code that you will be writing to complete project 1. Okay, I'm not I'm not guaranteeing that. But I'm going to be talking about a fair bit of it, probably most of it, possibly all of it, unintentionally, because I would like to give you guys a sort of a deeper understanding of how this API works. Because that's going to give you some ideas about how to structure your code, how to think about rendering in the context of, by giving sort of control to an API and getting interrupts from the API and all that. All right, so we're going to go through this in quite a bit more detail than I would normally do. All right, so we start with this. Yeah, so as I said, we're going to speak C++ today. We're starting with including our API. Now, you may run into problems even with this line. This is assuming that you're using GLOT, not FreeGLOT. If you're using FreeGLOT, you're going to have to include FreeGLOT, obviously. In macOS, in some versions, they decided to put GLOT under this GLOT/GLOT. It just comes with GLOT. It's there with some versions of macOS. Yeah, you might want to check it out, and if it's there and if it's not. Regardless, if you're using GLOT, please do place a copy of that under this directory, because this is where we're going to assume the GLOT header is while we're compiling your code. So that will really help us. If you could please copy that header to under the GL directory inside your include directory, wherever that is. Moving on. All right, here's our main function. So this is what your entire program will look like when you're using GLOT. There's going to be some initializations. We're going to do a whole bunch of initializations. And after the initializations, we're going to be calling this GLOT main loop. Here, this is where your code actually runs, where your application actually starts interacting with you, right? So this is when we start rendering images, and we start getting keyboard interrupts and mouse interrupts and all that. So we're going to be interacting with our code inside this function. Everything will be in here. And this is a function of the API, we call that, and GLOT will be handling everything for us. And once we close the window or give it an exit command, it's going to return from this function, and we can return from our main function and we're out. All right, so that's the main style of how GLOT works. Now, a windowing API does not have to work that way. I'm going to give you a counter example. That's going to be the other API that I'll talk about today. It's not going to work exactly like this. So this is how GLOT handles things, right? So let's begin with these initializations. First things first, call this GLOT init. Don't forget to call it, because, well, it doesn't matter what it does. These arguments are the arguments to your application, so probably they're going to be empty. And it doesn't really matter. Just call it with these, and it's going to initialize GLOT. All right. You just need to make sure that you initialize it so that when you call other GLOT functions, your program doesn't crash. All right. Just call this once in the beginning of your main function, and you're done. Yeah, you don't need to know much about that beyond this. All right, so it does the initialization. Now, when we want to generate a window that we can draw on, we will need this function. Right? We'll call just GLOT create window, give it a window title, whatever you like. There it is. That's going to open up your window. That's going to open up your window. Wait, we didn't say anything about that window, did we? Like, we didn't say what what would we would like that window size to be, or why would you like to place that window? Like if you want to do that, yeah, you can just specify it here. You can say, oh, I want to, here's the window size that I want, and here's where I would like it on my desktop or on my screen, and now create it, and it will create you that window. That's as simple as that. It's very, very easy to create a window. And you know what? This didn't just create a window. It actually did everything else that it needs to do to initialize OpenGL. So you can actually, after you create this window, you can start using OpenGL immediately. It's there. But we didn't quite specify what kind of OpenGL that we want. So if you don't specify this, what you get would be the default one, whatever the default is. Oftentimes, you may want to be a bit more specific. You may want to say, I want a particular type of OpenGL that supports certain things. For example, I can insert a function like this, glot init display mode over here. That's going to initialize the display mode with these three parameters, double RGBA and depth. So that means I want to have a depth buffer. My pixels are going to store RGBA values, and I want double buffering. I'm going to talk about what double buffering is, why we need it, and all that in a little bit. Right? So this is how we do the initialization. There are other initializations that you can do, but this is probably the most important one. And with these few lines of code, you will have a window. All right? Now, just having a window is not sufficient. Okay, I have this window, but I want to be able to do stuff with that window. Like, for example, I want to be able to draw something on that window. Well, if you want to draw something on that window, you probably do want to draw something on that window. You will need to tell glot which function you will be using for drawing on that window. All right? So the way we do that is by calling this. So glot display func. This is going to associate a particular function, your function that you wrote. It's right here somewhere in your code. You're just going to put the name of your function, and that will sort of register this display callback. So whenever glot wants to draw something on your window, it will call this function, your function, and your function will be responsible for doing all the drawing. All right, so OpenGL drawing calls will be here. Now I'm going to talk a bit more about this as well. But for the time being, just know that there exists a display function here. I called it my display. Call it whatever you like, and give it to glot, so glot knows that it's supposed to call this function. All right, simple enough. All right, so this is for drawing things. We also need to get some input from the user, such as keyboard. Right, so whenever I hit a key on the keyboard, I register this function, the keyboard function. Glot will call this particular function with this form. This is, again, my function. Name it whatever you like. It gets a character key, the key that was pressed, the XY coordinates of your mouse pointer, XY coordinates of your mouse pointer on that window when this key was pressed. So you get that as well. Do you need it? Sometimes you do, sometimes you don't. Well, a lot of times you don't. So most of the times you won't care about that XY, but if you want it, it's there, it's given to you. Right? Another funny function here, now this is our keyboard function, but this function gets a character key. But on our keyboard, if you look at a keyboard, there are keys here that are not quite, that they don't come with some ASCII characters. Right? So if there is an ASCII character for that key, this function is good enough. For anything else, glot has another function that's called special function. That's what it's named. So yeah, you can point to whatever function of yours that you like, and this one is, instead of taking an unsigned character, it's taking integer. An integer that has a specific value for each one of your keys. So glot has a specific integer value attached to each key on your keyboard, so you can access those keys like so. Any of the function keys, for example, if you hit any of the function keys, you'll be able to get the key into this function. Not the keyboard function, because the keyboard function does not have I mean, the function keys do not have corresponding ASCII values associated with them, right? But I have to say something that I keep using, and probably you guys will be using as well, what we call the modifier keys, Shift, Alt, and Control. They don't cause any of these interrupts, but inside those interrupts, you can check if the user was holding down the let's say Shift key or Control key. For example, if you hit Control F2, you'll get an F2 here, and you can check if the Control key was down. So that's how it works. Okay. Of course, we also need to get the mouse. Now, when you think about mouse, you might be thinking about the mouse pointer position, but no, you're not going to get quite that. This is associated with the mouse buttons. So if you click on a mouse button, Glot will call this function of yours. That's going to have the name of the button, left, right, middle, states up or down, and then XY coordinates of the cursor. So if you just click on some place, this function will be called twice actually if you just click, because you'll get one call for down, one call for up. Mouse button down, button up. If you want to, click on something and drag it around, you probably want to interact with your window in that form. You will need to register another function. That's going to be the Glot motion function. So this motion function is just going to give you the XY coordinates of your mouse pointer. Funny thing, this function is called only after you click a mouse button and then you move your cursor until you lift that button up. So you click, and then Glot starts calling this function as you drag your mouse cursor, and when you lift the button up, it will stop calling this function. So you can use it easily for dragging stuff. But if you want to be able to do things as the user is moving the cursor around, for example, you want to select something and your mouse pointer goes on top of something, and you want to change the rendering such that, I don't know, I have a teapot on my scene and the teapot changes color because your mouse pointer is right over it, right? Hovering over it. So for those kind of things, you kind of need to monitor the mouse motion while the user is not clicking on anything, like before you start clicking or dragging stuff. For that, we will need another function. For that, we will have this passive motion function. That's how it's structured. I guess there's some historic reasons for that. This also gets the XY coordinates of the mouse pointer. By the way, these XY coordinates are using the top left coordinates of your window. Top left coordinate would be that one of your window. Yeah, so that would be 0, 0. And as you go down, it's going to be increasing Y. As you go this direction, increasing X. This is actually the opposite of how OpenGL defines the coordinates. So the funny thing about defining the top left coordinates, you may think that this is natural. Of course, the top left coordinate is going to be 0, 0. What else? Well, if you do that, X coordinate becomes this direction, right? But Y becomes down, which is weird. X is this way and Y is this way, which is weird. That's why the OpenGL convention is the opposite of that. X, OpenGL uses this way. Y is supposed to be up. So in OpenGL, you'll see that in a lot of places, this bottom left corner is going to be 0, 0. All right, so the API differs from OpenGL there. Okay. So this is how I initialize all of my mouse-related inputs. There are other things that Glot has. There are a whole bunch of callbacks you can have. An example of that is this reshape function. For example, if you generated a window and the user decided to change the size of that window, you may think, like, why would I care? Well, you would care, actually, because that will impact the way that you will be rendering. For example, if you're rendering with some perspective transformation, or orthographic projection, regardless of whatever projection method that you use, you will need to know the view frustum, right? Because you're going to transform things to the canonical view volume. And if your window shape is changed, you would want to know, so that you can adjust your transformation matrices accordingly, right? So that's going to be actually something that you will be using in most of your applications. All right, moving on. The idle function. Here's another important function, and a function that you guys will need to be able to do some animation as a part of the first project, actually. So this glot idle function it's a funny name, but it's a function that is called when you're not doing anything. So like your application is done with all the OpenGL drawing and finished everything, and now we're waiting for more user input. And there is no user input. There's nothing to do. Like, what do I do now? So if you have any animations in your scene, that's the place. That would be the place to do the animations. For example, let's say that I'm displaying a rotating teapot. Teapot keeps rotating, right? As time passes, I'm going to have to rotate the teapot a little bit and render the OpenGL window again. Render the image in the OpenGL window again. This is where I will do it. So this is where I will know, okay, I'm done rendering the previous frame and everything else that I have to do. Now I can figure out how much time has passed and I can rotate my teapot accordingly, right? So this is the place to do it. So to summarize, I'm just giving you some of these functions. So this is a typical way of initializing Claude, right? So you definitely call this. Don't forget to call this. And after that, you may do a few initializations and then create your window and then register your callbacks so you can use them. And after you're done with this glot-related initializations, you're gonna need to do other initializations that are related to OpenGL probably. Right. But let's skip that. Let's say that we're going to do OpenGL-related initializations, and then what? Once we're done with OpenGL-related initializations, and we're ready, finally, we're going to be calling glot main loop. So this means that I'm ready to actually start the application. So up until you call this function, glot will not be calling any of your callbacks. None of your callbacks will be called before you call this. I believe this will start with calling the reshape function. So your reshape function will be called at least once, even if the user does not change the size of your window, that function gets called once. All right, once the glot main loop exits, you know that your program has done its job. You're ready to quit, and here you can just exit with returning whatever you want. So that's basically this is your main function, right? So I have this glot-related initializations, OpenGL-related initializations, and whatever else I need to do to initialize my software, whatever it is that I need to do, and then I call the glot main loop. And when I'm out of the main loop, I'm done. Okay, that's how it works. So let's talk about these OpenGL initializations a little bit. Now there's actually a lot that we're going to have to do here. For example, one of the things we're going to do is we're going to be setting a background color. So whenever we tell OpenGL to just clear the window, clear all of the buffers, we kind of need to tell OpenGL what to clear it with. We pick a color and that's how it's cleared. In this case, these are going to be the RGBA values. These are floating point values between 0 and 1. And 0, 0, 0, 0 is going to be black with alpha value 0. So fully transparent black, that's what it means. So you set that. Whenever you clear the screen, OpenGL will be using this color. All right. And there's going to be all sorts of other things that we're going to be doing. We're not going to be doing any of that for the first project, but for the upcoming projects, we'll be doing a lot in here actually. We'll be creating all sorts of buffers, initializing their contents. We'll be creating textures and initializing their contents. We'll be compiling our shaders. We can do some of these things multiple times as our software is running, but oftentimes we're going to do something first. I mean, you can change it. You can replace whatever you put in these buffers. You can change your textures. You can recompile your shaders and whatever. You can change the clear color during the course of your application while your application is running, but you'll probably need to initialize them once. If you don't initialize them, you're just going to get the default things. And defaults may be good enough for you for whatever you're doing. Maybe not. So, but in general, we're going to be doing a whole bunch of initializations here for this very first project. I think this is good enough. You won't need to do anything else. So I did GLUT initializations. I did this. I'm not needing any specific initializations for my application. So what happens? I call my main loop. Okay, I call the GLUT main loop, and the GLUT main loop starts running. And as it starts running, the one thing that it will absolutely need, and it will need your help with, will be this, the display function. So yeah, it created a window for you, but it's not drawing anything on that window. It doesn't know what to draw on that window. It's just the API gave you that window for you to draw. So whenever it needs to display something inside that window, it's going to call this display function. Now I'm being specific here, and I'm saying whenever it needs to display something. I'm not saying whenever you want to display something. I'm saying whenever GLUT wants to display something, it's going to call this function. So this is not a function that you should be calling yourself. This is a function that you should let GLUT call whenever it needs to, because this is going to be doing OpenGL rendering, and you need to render something with OpenGL and generate an image only when you need to generate that image. If you don't need to generate an image, you shouldn't be calling this function, because your GPU will be just working on. Like, for example, the image that you generated previously, if that's good enough, you can keep displaying that. Okay, you don't need to render a new image. So in an interactive application, if you have an animation, for example, something might be turning around, and you may want to update that image at every frame. You know, every time your display refreshes, you may want to update that. So you may end up calling this display function repeatedly. But sometimes you have an interactive application, but maybe it's just waiting for a user to do something. Now, I showed you a teapot, like what are you going to do with it? So until the user does something, your application will not be doing anything, right? You're just sitting there waiting for the user. At that point, there's no point in rendering the same image over and over and over again. So at that point, GLUT may or may not call this display function. In some cases it might, depending on how your operating system works. If there's a window on top of that, and that window is moved, and now the operating system needs to know what to draw on your OpenGL window, maybe it will ask GLUT to start drawing that window, and the GLUT will in turn ask you, that is your display function, to take care of the drawing. Right? So every drawing related stuff should go in here. I mean, there are reasons for putting your drawing related code elsewhere. There are reasons for it. There are cases where it might be a good idea, but your final drawing should be here. Okay, so this is the place to draw things. And so let's talk about this just a little bit more. How does this OpenGL drawing work? We're going to start with clearing the screen. So that's going to be fairly easy, just one call, say clear screen, so that initializes all the buffers. So in this case, if you clear the screen with this little bit here, that means I just want to clear all the colors, right? All the colors on that buffer, on that image that I will be rendering, clear all out. After we clear it, we are going to be drawing some things on it with OpenGL. We're going to be drawing probably a bunch of triangles. And then we're going to tell GLUT that we're done drawing. This image is ready. We're done. Okay? I'll tell more about this, but this basically signifies that we're done rendering the image. Right. But let's talk about this just a little bit more. Okay, this is clearing the color bit. What other bits can you clear? One of them is the depth buffer. So if you have a depth buffer, like if you're doing Z-buffer rasterization, you're doing 3D rendering, you have a depth buffer, yeah, you should probably clear that as well, because you're going to be rendering a whole new image now, rendering your scene from scratch. So you need to make sure that everything is cleared and initialized properly. Right? You can clear these buffers as you're rendering your image. So you don't need to just clear the buffer once and then draw. You know, you can use it for all sorts of different effects. For example, let's say that I have an object that I want to display, right? And my visualization is such that I also want to draw something that is inside of it. I want that to be visible. Well, if I use regular Z-buffer rasterization, I won't be able to see stuff inside other things, right? Because they're going to be occluded, and Z-buffer rasterization will take care of that occlusion. But for example, my visualization is such that I want to see it anyway, in which case I can just clear the depth buffer and draw it after I clear the depth buffer. So I draw my object, and then I clear the depth buffer and then draw it again. So you can do all sorts of crazy things here. But the main thing that the main way that we're going to be using this is the rendering is that we're going to be clearing the buffers. We're going to be doing all sorts of rendering in here, like drawing all sorts of triangles and whatever else is in our scene. And then finally, we're going to be calling this GLOT swap buffers. All right, so this is basically telling GLOT that we're done drawing this image. Okay, so let's talk about this bit a little bit. Why is this called the swap buffers? Like, what is this even? Well, this is related to double buffering. So let's talk about double buffering and why it's needed. Now, this is the window that we generated, and this, let's say that this is an image that we rendered, and GLOT is displaying this image. All right, and it will be displaying that image whenever it needs to display that image. Now, when we're rendering an image, we're going to be rendering triangles one by one. Right? We're going to be clearing that screen, and we're going to be drawing our triangles one by one onto that screen, following the rasterization pipeline. We probably don't want to show an unfinished rendered image, an unfinished image to the user. Like, we want to finish rendering completely, and then we would like to show it, right? So we don't want to show half of the triangles of this teapot while the other half are still rendered by our GPU. To facilitate that, we have this concept of double buffering. So we're going to have a secondary buffer here that's not going to be visible to anyone. It's just going to be somewhere in the memory, on your GPU memory, most probably. So you're going to have a front buffer that's going to be visible to the end user, and there's going to be this back buffer that's not going to be visible to anyone. So this back buffer is something that you can safely draw on, and nobody will be seeing it. Okay, so the user will be seeing just the front buffer, the contents of the front buffer, and won't be seeing anything. The back buffer is something that we are drawing on. Let's say that I'm going to take this back buffer, I'm going to clear it up, and then I'm going to be drawing my object. Let's say that I took this teapot and I rotated around a little bit. In my next frame, I'm rendering this rotated teapot that looks like this. So as I'm rendering it, I'm going to be rendering it into this back buffer. Once I'm done rendering it, that's when I'm going to swap the buffers. I'm going to swap the buffers. I'm going to tell GLOT, hey, I'm done rendering. You can swap the buffers now. And the GLOT will swap these buffers. All right? So now I'm displaying in the front buffer, I have the image that I just rendered. The image that I had rendered previously, which was previously in the front buffer, now is in the back buffer. So that's what we did, we swapped them. So for rendering the next frame after that, I'm going to be clearing this. Yeah, I'm going to be clearing this. And then I'm going to be rendering my next frame, right? So that's, and then of course, you swap the buffers again. So that's pretty much the workflow that we use with double buffering. GLOT will not give you, by default, it will not give you an OpenGL context that has two buffers. Yeah, you kind of need to initialize, kind of need to create these buffers and initialize them and all that, but GLOT will take care of all that stuff for you. You won't have to worry about it. You just need to tell GLOT that you want double buffers. And when you have animations, you really should use double buffers because you don't want to display an unfinished image to the user. So we're going to tell GLOT that we want to initialize OpenGL with double buffers. Remember this? This is double buffering. That's what it means. That means that I'm going to be using double buffers. Are there cases you would want to use more than two buffers, like triple buffer? Absolutely, and we will be doing that. Actually, yeah, in the past, we also had a left buffer and the right buffer and a few other buffers instead of just a back buffer and the front buffer. Things are a little more general today in the API. In the API, you just say, hey, I want a buffer, and you get a buffer, and you can draw whatever you want into it, and then you can use it however you like. But this back buffer and front buffer, that concept is very fundamental to what we're doing, right? So front buffer is what the user sees, and back buffer is what we are rendering into. So we need to have those two at the very least. You may want to have more if you're doing more complicated stuff, and we will do more complicated stuff in this course, so we will actually use more buffers. If I don't call GLOT swap buffers or call it twice, would the window always show the same front buffer despite all the OpenGL calls? Yes, if you call it twice, you're going to be swapping them twice, so you get your old buffer back. But something funny happens here. I was going to talk about it later, but I can talk about it now. So over here, this is our display function, right? So this is how it works. We clear, we draw stuff, and then we do GLOT swap buffers. Now, almost all OpenGL calls, not all, but almost all OpenGL calls will be what's called non-blocking calls. That is, I call GL clear, and this function returns immediately. It tells the GPU to clear the screen, to clear that buffer, and returns immediately. It doesn't wait for the GPU to actually clear that buffer. Right? It may take however long it has to take. Same goes for all of the OpenGL draw calls you're having here. So some of those draw calls may be quite expensive, and they may take several milliseconds. That's what it means when I say quite expensive in the context of interactive computer graphics. They may take several milliseconds, or maybe even more, maybe 100 milliseconds. Wow, it's really long. Yeah, so you're not going to wait for that. Your OpenGL calls will return immediately, and then I do all that stuff, and I call GLOT swap buffers. That returns immediately too. That doesn't mean that the rendering has finished and I swapped any buffers. So what's going to happen is that as we're drawing stuff, we're going to be sending all these OpenGL commands to our GPU's queue. So you queue up all these commands, and then you finally say, okay, when you're done, you swap the buffers. So that's what it means. This doesn't mean swap the buffers now. It means swap the buffers when you're done with all this stuff. That's what it means. Okay. So this is going to return immediately, and your CPU will be idle. Your GPU will be doing stuff because we gave all sorts of stuff to do to our GPU. Your CPU will be waiting idle. And that's when GLOT will be calling your idle function. Right? Your CPU is sitting idle now, we're waiting for the GPU. So you might as well do some useful stuff on your CPU as you're waiting for your GPU. That's not to say that this part is going to be slow. Your GPUs are pretty fast, and your rendering can be done pretty quickly actually. That doesn't mean that you're going to have a lot of time to kill in your idle function. You may not. And in your idle function, you can still issue some OpenGL commands and do stuff like that inside your idle function. You can continue using your GPU to do other things. How do we know when we are rendering to the front or the back buffer? That's a very good question, actually. So you can change the render target in OpenGL. You can render directly to your front buffer if you want. You can render to all sorts of different places on your GPU memory. And you can set the target for your render. You can say render into this buffer, into that buffer. You have that control. Now, GLOT swap buffers function will actually do these things automatically for you. So it will swap the buffer contents, and it will set the render target to the back buffer, to the new back buffer. Right? So if I have two buffers, let's say A and B, A is my front buffer and B is my back buffer. When I swap them, now A is going to be my back buffer and B is going to be my front buffer, right? So GLOT will set the render target to whatever buffer is the back buffer now. So it will do that automatically inside here. But yeah, you can set the render target as well. And in this course, we will be playing with setting the render target to different buffers because we will be rendering to different targets. All right, enough about double buffering. Idle function. Yeah, so this is where a lot of animation-related stuff is going to happen. This is the right place to put your animation-related stuff. Remember, we're still inside the glot main loop. So whenever glot is done issuing the draw commands or handling our keyboard and mouse inputs, it's going to be calling this function. One thing you'll need to do with a lot of animations is figure out how much time has passed since this was last called. Let's say I have an object that's rotating with a particular speed, right? You kind of need to know how much time has passed so you can adjust its rotation accordingly. You can actually ask glot, give me the current time, and you can, based on the current time, you can figure out how much time has passed. By doing that, you put all of your animation code here. And after you're done with your animation, well, guess what? glot was done with rendering your viewport. It was done with handling all of your keyboard interrupts and mouse interrupts and all that. Now it's calling your idle function. After this function is done, glot is done with that as well, but glot has nothing to do. So you may think that when you change things, glot will magically know that it needs to render again. It will not. So you will need to very explicitly tell glot that you need to draw again. All right? Whatever you were displaying in your front buffer is no longer valid because I changed some stuff in here and I changed some stuff in my scene. I need you to draw that again, please. Yeah, so you call glot post redisplay. Do not call your display function yourself. Just tell glot that you would like glot to call your display function. All right, so don't call it directly yourself. It will work if you call it directly yourself. But don't do that because that's not how glot is designed to operate. Okay, so for example, let me give you an example animation. What can you do? For example, you can change the clear color. Let's say that I have this variable red that changes the red color value, and I assign it over here. So every time this idle function is called, it's updating it, and it's also changing the clear color, and then telling glot to call the display function again. So this will animate the background color, although probably, I'm not setting any speed with which the red color is changing because every time it's called, I'm incrementing by a certain number. That's probably not a very good idea. You should probably check how much time has passed. And then at some point, this red value is going to reach 1 and will start going beyond 1, which is not going to be very helpful here. So, this is not a very good animation, but, a very, very bad animation example anyway. just to give you an idea. All right. Here's another thing that you're gonna have to do, like deal with the keyboard interrupts. This is the simpler keyboard function that's getting the ASCII key of the key that you just pressed. Handled it in here. So what do? You probably have something like a switch statement here, right? Based on whatever key was pressed. Let's say user pressed A, you do something with A, whatever you're supposed to do. For example, in the project description, I'm saying when the user presses the escape key, exit. So this is how you do it. Escape key corresponds to the ASCII code 27. So if the code is 27, you say glot leave main loop. That's the proper way of exiting a glot application. Telling glot that we're done. We're done with the main loop. You can return now. All right. But oftentimes you're going to be doing other things, right? I'm going to be doing something when the user hits a particular key. Okay. So let's say I'm changing the color of my teapot from something to something else. So I'm going to be re-rendering it. Will I be re-rendering it? No, unless I tell glot that I'm going to need you to call the display function again. So if you don't do this, glot will not do anything, right? Don't forget to do this. Whenever you need to re-render, make sure to call it. That's a funny thing that happens if you forget that. You will be updating your scene and nothing will change on the screen, and you'll be like, I'm changing everything and nothing is happening. Maybe you just forgot to do this. something to check. All right, this is everything that I want to talk to you about Glot. But before we end today's lecture, I also want to talk about this other API, GLFW. My goal here is not to give you a full overview of this API as well, but to give you an idea of how a different API may handle similar things. Right? So that's the whole point, just to contrast it with Glot. So this particular API is typically stored somewhere else, obviously the header file. Similar to Glot, you'll need to do some initialization. And similar to Glot, you'll need to create some window. Of course, it's using different functions because guess what? It's a different API. You can check whether or not it was able to create that window. If not, you can exit and return with some error code that you want. So that's a typical way of using this. It's just creating an OpenGL window with the default parameters with this size and this title and all that. But after that, we're going to set the main context. And so this is going to be this window is going to be our main context. And then we're going to be having this loop. Now, this is very much like the Glot main loop, but the Glot main loop is hidden from you. This one is not hidden from you. You actually write your own while loop. Okay, there's a while loop here. Your function, your application is running inside that loop, and when you exit that loop, you terminate. Right? You call this terminate just to clean up things, and then you return. Right? So it's just this particular API handles this looping concept a little bit differently. This is more typical of windowing APIs. They typically handle it like that. Glot is more like a special case, but obviously there are APIs like Glot as well. So in here, this display function is over here, right? You see, like this is the whole display function in Glot. It's in here. Of course, you can separate it out and make it a function call if you want to. It doesn't have to live inside your main function, obviously, but it can if you want to. It's just that you're going to have to handle it yourself. So you do all the OpenGL drawing here, and guess what? After you're done drawing, you specifically call this poll events. So if there are any keyboard and mouse events that need to be handled, you're going to have to call this explicitly. In that respect, this API gives you a bit more flexibility in the way that you want to handle things. For example, you have a particular animation. During that animation, you want to ignore all the user input. I don't know why you would want to do that, but you can do it if you want to. So it gives you a bit more control over how you want to handle your application. Glot will hide this loop complexity from you, but nonetheless, you kind of need to understand that that loop exists in Glot, right? So you kind of need to structure your code accordingly. So in that sense, I'm not sure that it's hiding much from you, but at least you don't have to write that while loop if it's any simplification for you. Anyhow, so it's a different API, works differently. Nonetheless, there are different APIs that you can use. As I said, if you're not sure about which API to use, I'd say use Glot. If you like this while loop option a little better, you can use GLFW. If you really, really like Qt, you can use Qt. If you like some other library, you can use some other library, whatever that is. But just be warned that we will be supporting Glot in this course. So I'm not making any pledges here that I will learn and tell you how to do stuff in any API that you can come up with. Okay, I'm not saying that I will do that. So we will give you support on Glot. So if you're not sure how to use another API, I would say don't use it. Just use Glot, because we know how to use it, and we'll tell you how to use it if you have any problems with it. But if you know another API and if you really want to use it, yep, go ahead and use that. And again, as I said earlier, not today, but earlier, you don't have to use OpenGL in this course. If you want to use another graphics API, you will probably need to use a windowing API that supports that. All right, then we're going to end it here. I'll see you all next week. And until then, stay safe and good luck with the first project.